Okay, so continue our discussion on the microcontrollers in this part of the work. So in the previous video, we have more talked about the supplies, power sequencing, crystal oscillator, and the boot options and the programming options. So we'll proceed further, and then the next point would be the bootloader circuit. So bootloader circuit is basically required if you have a serial port and if you want to use a program for a serial port or a USB. So there will be a separate bootloader circuit that need to be built. So most of older microcontrollers have these bootloader circuits where there was a RS-232 input. So most of us should be familiar with it. And then the reset circuitry. So reset circuitry is required like the case of a supervisory IC where it is supervising the IO supply. Let us assume IO supply is 3.3 volts here. So if the voltage falls below 3 volts, for example, which is the minimum volt, let us assume that is the minimum voltage for the microcontroller. So when it falls to 3 volts, the supervisory circuit will issue a reset to the microcontroller so that the microcontroller would be in reset condition until the supply comes up to the required nominal voltage. So a specific reset circuitry should be built, and then when we say reset circuitry here, there is a specific requirement for the microcontroller power to be given at a specific ramp up time. The rise time should be controlled. So wherever you see a microcontroller design, there will be a simple RC that is used at the input of the power supply. So that controls the ramp up of the voltage to the microcontroller. Talking further, and definitely when a microcontroller is used, you will have a number of peripheral interfaces, which here we are talking about the serial interfaces. Like assume I wanted to connect a memory interface which has a I2C or SPI, like take the case of a EEPROM. So there will be I2C, SPI, UART. UART, as I talked about, that could be used to load program or to use a simple serial application. And then CAN, everyone knows it is a hot in automotive industry. USB, right now the industry is more moving towards the USB relay circuitry and ignoring the UART because of the speed or the connector form factor. And then the Ethernet is like if you want to connect it to a network, it is required. The advanced microcontrollers have DDR, like if you take a microchip PIC32s have the DDRs, and then the I2S is used for audio interfaces. So these are all the different interfaces that are there. So when you talk further on these on the hardware level, I2C you have to take care of pull-ups in your board. SPI, you need to have pull-ups for the clocks, and then series termination if you are running them at a very high speed like 50-60 megahertz. And then CAN requires an external transceiver to the microcontroller along with the termination of 120 ohms. And then USB also requires a termination which is 90 ohms. And then DDR, if you are using, based on the type of DDR, your termination will vary. So at the hardware side, you have to take care of all these terminations. Moving further, other than the serial interfaces, there will be interfaces like analog, which we call ADC, PWM, pulse width modulation, the comparator, DAC, digital to analog conversion, and RTC, real-time clock. So for the analog, you generally look at the signal conditioning. What is meant by signal conditioning here is when you have a sensor or something which operates at 12 volts, you need to connect to your microcontroller, but your microcontroller is operating at 3.3. So in that case, you need to down convert and also impedance match the circuitry. So we will talk about impedance matching and all. So that signal conditioning is what is required for analog. And then PWM, just a pulse generation for your basically the motors and all. And then RTC is used for timekeeping requirements. And we'll talk about further, there will be several packages that are required that will be there for the microcontrollers. It could be a TSSOP, BGA, LQFP, or the DIP. So you have to take care of your package requirements while selecting it and place on the board appropriately. So these are all the hardware things that we look at when we are designing a microcontroller board.